Hello, everyone, and welcome to the July meetup for OWASP Ottawa. Hope everybody is staying safe and socially distancing and wearing masks. Today, I'm particularly excited. Well, I'm always excited, but today I'm particularly excited because we're going to talk about secrets. And as we sort of all rush to the cloud and want to deploy on the cloud, we're in a situation where we have to protect things, and secrets are involved, and these are often a foundational element to any deployment in terms of how we manage, control, and rotate secrets. So we're not dropping them as hard-coded in a Git repo, but I know that never happens. Anyways, I'm really excited to welcome Abhay Bhargav, who is the CTO at We45. He is the chief architect of Orchestration and leading application vulnerability correlation and orchestration frameworks. His pioneering work in DevSecOps and AppSec automation, including the world's first-hand training program on DevSecOps, focused on application security automation. And as we all know these days, we're trying to automate all the things. He's also been active in researching new technologies and their impact on application security, containers, and orchestration of serverless, say that 3 times fast, serverless architectures. And we're really, really happy to have him speak. Welcome, Abhay.
Hi, happy to be here. Thanks so much, Garth, and of course, the OWASP Ottawa team. Thanks for making this happen. All right, so very happy to be here, and I'm going to get started in just a second. So just making sure.
You have a sweet background crib there, Abhay.
It's not. It's clearly some amazing AI and that's going on, but making this happen. So anyway, yeah. So first of all, thanks again for OWASP Ottawa. I do realize I had to reschedule, but I'm really happy that we could do this and that I could get an opportunity to talk. It's really nice that this could get done. First of all, very happy to be here. This is the first time I'm actually addressing a chapter in Canada, which is very interesting because I really thought it wouldn't take this long for me to do this. I've spoken in a lot of OWASP events, but somehow, for some reason, Canada has never happened. So I'm really happy to be doing this for the first time for a Canadian chapter. So without further ado, I'm going to just share my screen, and we're going to get running. All right, I'm guessing everybody can see my screen because I can see my screen. So
I can see it.
All right.
Looks good.
Yeah, thank you. Yeah, thanks. So today's topic is a hitchhiker's guide to managing secrets on the cloud. Now, this, like Garth rightly pointed out, is a very important topic, especially because a lot of us have moved to the cloud. Some of us, of course, have been a little bit more meticulous about it, and some of us, well, not so much, right? The cloud has been something that a lot of organizations have kind of hurriedly jumped into and sometimes not thinking too much about the ramifications. At the same time, we're seeing a slightly different thing happen with secrets in general. And let's talk about both these things, and let's look at it in the context of the cloud and secrets management in the cloud and certain things we can do to do a better job of secret management in the cloud. The talk is largely going to focus on what are the possibilities. I'm not going to go too deep because secrets, as you can clearly imagine, is a pretty large and complicated topic. So I'm going to talk, I'm going to give you like a roving view of the whole landscape, and then also do a couple of demos if possible, if I do have the time. And I do live demos, so hopefully that goes well, right? So let's get started. A quick introduction of myself. My name is Abhay. I run We45, and I also, so previously I started off as a pen tester, typically somebody doing security assessments and pen testing. But over the last 5 years, I've seen a pretty large shift in my role towards making application security scale, right? And that's what a lot of us want to do today, especially small organization, large organization. It doesn't really matter. All of us want to make application security more scalable, more part of the SDL, which is essentially what you might commonly know as DevSecOps. So a lot of my work over the last 5 years has gone into this attempt at doing application security at scale. As part of that, I've done a few things. One is, of course, I've built our product on vulnerability correlation called Orchestron. Orchestron is essentially is meant to manage all the massive data that is coming back from your scanners and tools that are part of your continuous integration pipeline or your DevOps pipeline. So that's what Orchestron is for. Other than that, I'm also very involved in the open source world. I run a pretty, I would say, a pretty important open source project called Threat Playbook. It's a really nice project in that it helps you do threat modeling as a DevSecOps process. So you can do a lot of automated threat modeling and threat modeling as code. So that's one of, it's a passion project of mine. It's on GitHub. So if you want to check it out, contribute to it, please do. I'll probably share some links at the end. So that's one project. I also have written another project called DVFAS, or Damn Vulnerable Functions as a Service, which is an intentionally vulnerable serverless application or serverless suite of applications that you can deploy and actually compromise to see how you can actually learn serverless better. Other than that, I do a lot of training. I'm a lead trainer for V45. We do a lot of training at different events all over the world. In fact, next Saturday, I'll be training at Black Hat. This year, unfortunately, I'm not at DEF CON, but over the last 3 years, I've done a lot of workshops at DEF CON. A lot of OWASP events as well, other than all of these events. So if you are at any of these events over the next couple of months, of course, all of us have to do this virtually today. So we are at Black Hat, of course, next week, OWASP, multiple events, Echo Party, Shack, Hack in the Box, and so on. So you'll pretty much catch our trainings at all these events. We do a lot of trainings around Kubernetes, containers, serverless, generally kind of the bleeding edge of application security, so to speak, right? DevSecOps and so on. Other than that, we also have a pretty active YouTube channel. You should check it out. We do a weekly live code session, so it's pretty interesting. A lot of a combination of defensive and offensive stuff. So it's not always just compromising stuff. We talk about a lot of defense as well, and we do a lot of talks like this at different OWASP events. So I'm going to get started with my talk today, but before that, I am going to say a quick prayer to the demo gods. I do have one reasonably large-sized demo that I have to explain, and as you know, live demos can always go terribly wrong. So I want to make sure that this one doesn't. So I'm just hoping that everything goes well, right? Just saying a quick prayer to the demo gods. Now today it's going to be a pretty simple talk. I'm going to start off with the challenges, especially with secrets, and this has become a pretty big challenge in that we are seeing this accelerating as a challenge, and I see that this is a challenge. At least in terms of the scale and scope of the challenge, it's only getting bigger. But thankfully, in the cloud, you can get it under control. You can implement things that can bring some kind of a method to the madness, right? So that is something that you can do with the cloud. And of course, let's talk a little bit about cryptographic services in the cloud. I largely come from an AWS background, but I do have some level of expertise with Azure and Kubernetes and so on. But typically, you will see that there is a large thread of commonality between all of these different cloud providers and the kind of secret and cryptographic services they offer, right? So that's something that I'm going to be talking about towards the end of the talk, as well as following that up with a quick demo on AWS as well. So that's something that we're going to be doing today, right? Now I'm going to have to address your questions typically at the end, because when I have the slides on, I can't see anything else. So I will try and address the questions at the end. So please, if you have any questions, please type it in or however you want to do this, and then we can always address them at the end, or whenever I change my slides to start the demo or something like that. That's when we'll have to do that. All right. So one of the things that you might have noticed is, especially as most of you, I'm sure, are dealing with this, or you might have been at the receiving end or the giving end of this, but either way, you're dealing with this, right? So we have, especially with the kind of apps that we're building today, we're dealing with a lot of secrets, right? So we're dealing typically with a lot of secrets, and a lot of times these secrets are sprawled all over the place, right? So a lot of times you'll see that secrets are seldom very secret. So things like this, right? Simple Google Doc can give you all of this stuff, .env files with Laravel settings of the crypto, with the environment variables, with the passwords, with application keys, encryption keys, what have you, database connection strings. This is all on the open internet. Of course, with Git repositories, we all know this to be a very popular way of getting your accounts compromised and your applications pwned, right? Because you have a lot of folks check in the secret and then they delete it, and then they think they've actually deleted it. A lot of times we have the situation where they say, I deleted it, but then they don't realize that the actual the content of that particular secret that was supposed to be a secret is no longer a secret. And this is really a bad situation to have, because Git has a history, it remembers everything, and this is one of those things that can go really bad. And in fact, if you look at the cloud, in fact, I was just having a Twitter discussion about 2 weeks ago, and on the cloud, one of the things we've noticed is that there are very few pre-exploit things, right, which are very cloud-centric. Most of the cloud-based exploitation scenarios really happen once you've compromised. And one of the most common ways of compromising any kind of cloud environment is to get access to the session, the secret key, the token, the secrets related to accessing that particular resource on the cloud. From there, the attacker that's when the attacker establishes that initial connect and then pivots into other services on the cloud. So if you look at the Capital One breach, you look at the one that just happened, I think yesterday, where Twilio just said that their S3 bucket was compromised. Of course, that doesn't relate to secrets so much, but Capital One directly does, because they had that WAF compromise, and that WAF had gave rise to an SSRF attack where they were able to compromise a secret, and that secret, which was the AWS key and the secret and the token, they used all three things, and they were able to gain access to the S3 bucket and steal a bunch of data from that S3 bucket. So most of the scenarios really start with you gaining access to these things. And the cloud is a massive storehouse of secrets, because your apps today, you're dealing with API keys, you're dealing with encryption keys, you're dealing with environment variables, you're dealing with OAuth secrets, you're dealing with a ton of stuff. So this is one of the big challenges that we're dealing with. And when you do that, you're essentially, and especially when you're dealing with things like microservices, then you have an exponential spread of these secrets, right? Because one service may have its own set of secrets, another one may have its own set of secrets, and you're dealing with like a ton of them. And when you don't have a way of managing it really well, or having a designed, well-architected approach to managing these secrets, you have sprawl. And when you have sprawl, you have compromise, and of course, we all know what happens then. So one of the big challenges that we're seeing is that we are delivering apps at massive scale. We're also producing or consuming secrets at massive scale, but we're not necessarily protecting these secrets at that same scale or with that same seriousness. So that's one of the things that I just want to start off with. So that's one of the most common things that you see with secrets, is that you deal with the sprawl without having too much of a method, especially if you don't architect for it. A lot of times we see these very, very common examples of secrets, right? You store them in environment variables, or you store them in key rings, or you store them as a GPG. I mean, GPG is a pain to work with, so you'll probably see that storing them in all of these different modes is one of those things that can go horribly wrong. In fact, in things like when we do an assessment in the cloud, like an AWS assessment or a pen test on the cloud, one of the first things we do is try and establish these kind of things, right? Look for environment variables. A lot of times environment variables have like a ton of secrets, like passwords, database connection strings, API keys, encryption keys, what have you, right? All of this is typically loaded a lot of times in environment variables. You also often have them in things like key rings and keychains. Again, this is slightly better than environment variables, but then again, if somebody has remote code execution and they gain access to the backend operating system or the operating environment that you're running in, then this becomes very easy to do. This becomes very easy to exfiltrate. It's very hard to maintain any kind of control over key rings and keychains. And of course, let's not even talk about GPG, because that's really horrible, right? GPG is not exactly one of those things that you want to deal with. It's a pain to work with. You have to deal with a lot of these, this relationships of having to get that user's key and then use that key, and share it, and it becomes a painful access control model. So environment variables is a complete compromise, especially if there is any of these things, right? Remote code execution, server-side request forgery, injection of any sort. Or a lot of times you would see that this becomes a very common exploit possibility, especially when you're dealing with CI tools, right? So let's say you're running a Jenkins or some other kind of CI tool. Obviously, that's going to be a giant storehouse of secrets that will have. And when that is compromised, I say when because most of these CI tools are always waiting to get compromised, probably already are compromised. So a lot of times you'll see that CI tools, you would have the same kind of scenario where environment variables are definitely compromised. Now, key rings and keychains, again, it's a little better. It's just a little better. It's not better by much. It's difficult to secure simply because you have containers. When you're dealing with containers, you have a lot of these access control, access control slip-up areas that can go terribly wrong and becomes a little difficult to control. And key rings and keychains, while they're okay for a basic use case when you're dealing with apps at scale, this is not the way you want to scale. You will not be able to scale, especially like this. And of course, let's face it, you would rather use anything else but GPG, right? Literally everyone in the crypto community hates GPG or PGP, and you'd rather use anything but this, simply because of the sheer complexity of the APIs, the sheer complexity of having to manage the access control model. It's a pain to work with, especially in terms of a service. So we have this. These are a little bit more native, but however, these are pretty popular, especially the first one. There are very limited scenarios in which you walk into an application environment or you're assessing an application environment and you won't see a ton of these environment variables with plain text, that somebody can access and gain access to. A lot of times these environment variables make their way into logs, they make their way into repos. It's a mess. So the first one is probably the most common pattern that you can see, but that's one of the challenges that we're dealing with. And remember this is all with that massive sprawl. You're still dealing with that massive sprawl effect simply because you don't have a very good approach to doing this, a well-architected approach to doing this. So, and the big thing with secrets or any secret management solution, so to speak, is access control, right? Now, when you're dealing with secrets, you need to make sure that those secrets are access controlled. They are only available to authorized apps or users. But with these more native technologies and native approaches to storing secrets, it's nearly impossible to do that really well, right? The other major point that I want to talk about today is accountability for the secrets. Now, who accessed the secret? When was that accessed? Who was the user, or which was the application that accessed the secret? Now, this is again nearly impossible. Even if you are a Linux genius, even if you're amazing at figuring out some journal D or audit D capability that will help you do this, it's hard to do accountability for these native secrets management approaches that we have. And the last thing, it does not provide for any kind of change, right? Now remember, secrets are subject to change. And when you use an encryption key, you want to rotate it every so often, typically once in a year or once in 2 years, depending upon the kind of criticality of data you're carrying. So they don't provide for any kind of rotation. And if you are, I used to be a PCI auditor a long time ago, and I've seen nightmare situations where companies have not planned for key rotation, and they've had to deal with a scenario where they have millions of data sets that is encrypted with a previous key, but the standard, the compliance, the new security mandate is to implement rotation. So which means that they need to go right back to the architecture. They need to figure out a way to do rotation in the first place. Then they need to figure out a way to migrate all that data. First of all, implement it in the application or applications, usually in plural in most cases. And of course, provide for a situation where they re-encrypt all that data that they're previously encrypted, which again could be in backup disks, it could be in the production database, it could be in several other databases. So it becomes really complicated if you do not provide for rotation. And with most security standards, and I'm talking about, I'm not just dealing with compliance, although compliance is a big driver for rotation. Even if you are not doing it for compliance, and even if you are doing it for generally a good security approach, which you should, this is a pain to do if you don't use, if you don't think about secrets from a design and architecture standpoint, right? Think of it as an architected solution in itself. So that's something that you have to definitely think about. So secret sprawl, it's like I said, it's all over the place, right? So you see this in Git repos, you see that in issues, you see this in the application. Of course, a lot of hard-coded secrets around, right? Especially with mobile applications, hard-coded secrets are just a gold mine. It's just amazing to find hard-coded encryption keys in a Android application that the developer thinks, hey, nobody's going to be able to reverse engineer this. Who can reverse engineer an Android app? So you will typically see that the hard-coded secrets are very common in a lot of cases. Or if you're using bad encryption of any sort in the database or in logs. I didn't write logs here, but logs are very common. In fact, I was just going through the trail of bits Kubernetes audit report today, and apparently Kubernetes logs all auth tokens in the Kubernetes log file, and they've still not fixed it. So if you are running a Kubernetes cluster, be prepared to have a lot of these logs, the auth tokens in your log files as clear text. I think they're either just fixed it or they've still not fixed it. I'm not 100% sure, but it's a very, very recent thing. And even in a product like Kubernetes, which has been around, which is actually considered to be a state-of-the-art DevOps implementation, so infrastructure implementation. So you have, of course, CI/CD tools. You can have this in your job configuration files, in your state files, in your environment variables, and infrastructure, of course, and settings, config. A lot of these places you have this kind of a sprawl. And sprawl, remember, sprawl today is at scale. It's not like you're dealing with one SMTP password, one database password, and it's not like a very old school app that had very few things that you had to deal with. Today's applications, you're dealing with a ton of different secrets, and a lot of times this can be a pain to manage, especially when you're doing this at scale. Now, one of the things that really I feel democratized or made things much easier to do is with Vault, right? So I'm not sure how many of you have experience with Hashicorp Vault, but I think it's one of my favorite products to do secret management because it's so great, so extensible, and it really came. I came from this whole world of having to deal with really horrible cryptographic API or APIs that deal with hardware security modules and cryptographic implementations. The APIs were so bad that it was really a pain to work with. In fact, 10 years ago when I used to train on application security, I used to tell that implementing crypto is really hard today because of all these problems. But Hashicorp Vault came along and really made things so much easier. In fact, when I saw it the first time, it was love at first sight when I saw that product, and especially the fact that it's open source is just a cherry on the cake. It's truly an amazing product. The fact that it's open source makes it so much easier to work with, and of course, it does have an enterprise variant, and that's fine. But the open source version is just as functional, and you can do, except that you don't have some of the more advanced capability, but you still have a lot of capability to make sure it's really powerful stuff. So I really, one of the things that it did for secret management is kind of woke everybody up to the possibility that, hey, secrets management can be this good, or cryptographic services can be this good. You can actually implement it and do a good job rather than trying to shoot yourself in the foot. So this is something that Vault really brought to the table. And I see a lot of what Vault has brought to the table has been used in designing services on the cloud. So if you look at AWS, you look at Azure, you look at Google Cloud, you see, and you look at Vault, of course, you will see that all of these services have the same set of concepts, right? A very similar set of concepts, the way they go about implementing things, the way you can go about doing envelope encryption or doing secrets management or key value secrets and all of that stuff is very similar in all of these different products. You see that there is that standard thread of doing things, right? So you'll see a lot of commonality in handling this. Of course, in the cloud providers, this has definitely gotten a lot better. I'm happy to say that this is one of those security stories that has actually gotten better with time, and in fact is getting better. In fact, AWS just towards the early part, or towards, I'm not sure, the early part of this year or the end of last year, they they provided more asymmetric encryption capability to their encryption API, which is the key management service, beyond the already good symmetric API that they did. So cloud providers have definitely taken on this challenge and delivered a great set of solutions. I really have to say that they've done a great job. Now, previously, when you had to do this, when you had to do a good job of this, you typically had to be a financial institution or some other an entity with deep pockets, and these they had to buy these hardware security modules that handled encryption, key management, and stuff like that. I'm not sure how many of you deal with it or have dealt with it in the past, but this was the way that it used to be done, especially when you wanted to get it right. If you wanted to do encryption right, and even then it would be a pain because these security tools, these security modules would have bad APIs. They would not be very interoperable. It would just be a pain to implement. So one of the things that all of these cloud providers did was they kind of gave you access to the same hardware or similar hardware and just time sliced it up. Sliced it up so that you could use it in a multi-tenant way. So one of the things they've done is taken really tried and tested cryptographic implementations or cryptographic technology and made it available to everybody at a sliced multi-tenant kind of a price. So that's one of the benefits that they've provided. So I really have a lot of respect for the work that the cloud providers have done. All of them. I'm not singling out one or the other. I see that all of them have really done a great job when it comes to secrets and encryption. Right. So let's look at some of the solutions that you have. So secrets management on the cloud, you do have the native ones itself. So AWS is 3 products that do secrets and encryption. So I'll get to secrets versus encryption in a little bit. So encryption is a little bit more foundational, right? So it encrypts any data. So it's a more generic service, right? So an encryption service like the AWS KMS is a more generic service. So what it does is that the API lends itself to any encryption use case. So let's say I want to encrypt an object in S3, I can use KMS. Let's say I want to encrypt an entire database, in the file system, I can use KMS. Let's say I want to encrypt my EC2, file system or disk, I can use KMS. So KMS is this generic encryption library that gives me the encryption APIs or essentially manages encryption for a lot of these services. A lot of times, if you enable server-side encryption on S3, under the hood, it's essentially using AWS KMS to just run encryption at rest, right? Or encryption for data stored at rest. So that's automatically done in many cases. Now, that is encryption. That's a more generic service. That's like a more, that's like the foundational service. But then you typically have another use case on top of that, which is secrets management, right? So that's secrets is a little different, where you're typically dealing with a key value pair. So which means that let's say I have an application that has a database password. I don't want to store that database password as an environment variable or, heaven forbid, hard coded. I want to store that in the secret solution. I want to be able to query it as a key value pair. So I'm going to be able to query, hey, Secrets Manager, give me the database password, and Secret Manager fetches the database password that I can use at runtime and use that password at runtime. So that is a different use case. Now, under the hood, even that uses the encrypted, the KMS API. So the KMS or encryption APIs are typically the bedrock on which other secret solutions and your own application-driven secrets are managed from that standpoint. And Azure is very similar. Google KMS is also built on the similar set of principles. Now, AWS is the only difference here is that AWS has 3 distinct products for this. So KMS is used for encryption, and you can use that for encryption. A parameter store, you can use that for storing these key value pairs. Secrets Manager, you can also use for the same thing. There are some differences between parameter store and Secret Manager. I'm not going to get into that too much because, again, I don't want to make it too specific to one provider, but you can store these key value style secrets. When I talk about cloud, I can't, of course, ignore Kubernetes. Now, Kubernetes, one of the things with Kubernetes is that by default, Kubernetes does not do anything by way of encryption, right? By default, if you just set up a cluster on Kubernetes and you just store And the weird part is when I started working with Kubernetes about 2.5 years ago, the first thing I noticed was there was an object called secret. And I was like, wow, Kubernetes is great. They've automatically given you an object to store secrets. And my assumption was that it was encrypted. But when I used the secret, I realized that nothing was encrypted. It's just an object that helps you store a secret. Doesn't mean it's going to give you anything by default. Weird. But that's the way Kubernetes typically works. Now, Kubernetes, of course, has its own encryption services that are built on top of Kubernetes that you can optionally use. Or you can, of course, use additional solutions like Vault. I tend to use Vault because I already use Vault for on-prem stuff. So using Vault for Kubernetes makes it much more extensible. So I really like using Vault. Of course, you have different options. You have some Git-driven stuff like sealed secrets, and you have another tool called Camus, which is more application-driven encryption. But Vault gives you kind of the whole length and breadth of the kind of services that you need from Kubernetes, and you can do that with Kubernetes. Of course, you can deploy Vault on the cloud as well. It doesn't mean that it's only on Kubernetes. Right. So, like I said, I want to make that initial distinction between secrets and sensitive data, right? And this is the distinction between secret management and encryption services, right? So secrets management is typically key value pairs, right? Your passwords, your API tokens, your database connection strings, your keys, your any other thing that you want to store secret as a key value pair. So the access pattern is typically a key value pair, right? So the access pattern is, hey, secret manager, give me the database password. You get the database password, authenticate your database, and you're connected. Or, hey, secret manager, give me the token to connect to my OAuth provider, and that's the token you get to connect to your OAuth provider. It's typically a key value kind of a transaction that happens. Whereas with encryption, that's typically a little bit more, that's a little bit more involved, especially when your application is dealing with the secret in question, right? So let us say you want to store card numbers and in your database, right? So you want to store credit card numbers in your database, and you want to obviously encrypt it. You don't want credit card numbers lying around in plain text. So you want to encrypt credit card numbers in your database table in the attribute credit card number. Then you'll have to run a slightly more complex thing. You'll have to obviously figure out you'll have to obviously fetch your key from the key management system, then use that key to encrypt your data, and then of course if you're handling the encryption, then you probably need to worry about the algorithms, stuff like that. Once you do that, you have to store it. Once you have to use that data, you have to decrypt it. So you're typically dealing with a more data centric or a more foundational activity here. Now, secrets typically are encrypted with the keys, right? So that's just the distinction I want to make. Now, let's quickly talk about some of the principles of good secret management. One of the first things that comes to mind is versions, right? Now, versions, you would think, why are versions important? Secrets are secrets. Why do I care about the versions? Now, remember, you are dealing with an application or a set of applications that are rapid release. They probably change a lot, at least in many cases, not always, of course, but in many cases. You want to be able to version control your secrets, right? A lot of times you might have things changing. Your database credentials are changing, or something else is changing. Your client secret to your OAuth provider has changed. You have to regenerate it after a year. You want to be able to manage the versions, simply because you also want to be able to query the older version in case of scenarios where you need it, right? So you might have to query across different versions of your secret to be able to gain access to that, right? So that's something that you have to keep in mind. The other big thing, probably the top 2 or top 3 items when it comes to secret management, is access control, right? You want to be able to restrict the access from your application to the service that is managing keys and secrets. The reason being, you're essentially centralizing secrets in this service. And if you don't do a good job of access control, you're going to have an attack where the attacker could potentially use your application as a conduit, gain access to your secret store, and literally exfiltrate the entire secret store without access control. So inherently, building in access control checks is one of the things you should do and you should keep in mind. On the cloud, this becomes even more important, because on the cloud, remember, a lot of us give very, very loosely scoped permissions for our cloud resources. So if you have an application that's talking to AWS KMS or Azure Key Vault, you need to make sure that it only has access to those specific secrets that it needs. Simple, straightforward stuff, least privilege. All of us think that, I'm sure people do this, but you will be surprised as to how many times you would see star scoped permissions, which gives access to everything. So if that application is popped, your entire cloud secrets are gone, right? It's essentially considered compromised at that point. Audit trails, very important. And audit trails are important from two perspectives, obviously. One perspective is general, obviously, capability to account for what activity has happened, and of course, part of a good security program. The other audit trail is also required for your compliance and your regulation and your contractual requirements that you have. So remember that audit trails from a secret management solution are very important. With AWS, Azure, all of these are provided to a certain extent out of the box. So that's something that you have to keep in mind. And of course, key rotation. Now, key rotation is one of those things that you need to do simply because, remember, your key might get compromised, or there might be a scenario where you have to do this as a hygiene thing every year because of your regulatory or compliance requirements. You need to have a system where rotating your keys doesn't mean you need to schedule 3 days of downtime, right? Rotating your keys should mean that your data should be able to query with the old key and still actually manage and then re-encrypt and rekey over time, rather than having to deal with, okay, we need to rekey millions of records, so we need to bring it down and then bring it back up. That doesn't work. So key rotation has to be seamless and has to be a rolling deployment, rather than having to schedule this downtime and then figure out how to handle the uptime. So, and of course, you need to be able to handle security exceptions, right? One of the things that you should do, and this is something that the cloud providers give you the features for, but don't necessarily do it themselves, right? So things like, hey, when somebody is trying to access this and there's an access exception to your key management service or your secret management service, that's when you need to have some kind of a alert or some kind of an anomaly detection or anomaly. So this can be done again with some rules and some kind of CloudTrail, CloudWatch kind of rules. You can actually add this and then capture anomalies, capture exceptions, and use Slack or other reporting tools or other, investing PagerDuty or whatever it is to be able to actually find and triangulate the issue before it can actually go really, really bad. So this is really a question of secrets, right? So this is good secrets management. Like I said, secrets is essentially, I'm talking about the key value based stuff that I'm looking at. Now let's look at encryption services. Right? Now let's look at encryption services. Now encryption services, like I said, is a slightly more involved activity. That's when you need to consider all of these different things. First of all, the key itself, right? The key, what kind of a key, what is the algorithm, what is the key size, etc. The good thing is all of the cloud providers give you high quality, or they start off with a pretty strong algorithm baseline, a key size baseline, and a mode baseline, right? So all of this is pretty strong from the get-go. So your AWS typically starts off with AES GCM. They give you access to RSA with the right OAIP padding and all of that stuff to make sure that your keys, them by default, are secure in the sense that they are strong cryptographically generated keys, rather than giving you the option of choosing, hey, do you want to choose this insecure mode or this insecure algorithm? They start off with a high bar, right? So that's one of the good things with key generation. They also give you a lot of capability to do key rotation. Now, AWS, Azure, or Google Cloud allow you to actually rotate your keys. In fact, you can do this on a scheduled basis. So you can say that, hey, rotate my keys every 365 days, and they would automatically handle the key rotation process for you. Right? You will need to still rekey your data with the new key, but that's something that you can do incrementally rather than having to do it as this one big bang thing that you do. Right? Of course, they give you the two things, which is access control and audit trails. Now, both these things are very important for the same reasons they're important when you're dealing with secrets. And they give you one more important thing, which I'm going to talk about at the end before I go into my demo, which is called envelope encryption. So I'm going to talk about this a little bit before I go into my demo. So when it comes to AWS and Azure and Vault, these are some of the comparisons. They give you symmetric keys. So when I say CMKs, they're essentially the master key. So each service allows you to generate or use certain master keys, and you can generate a master key, and the master key by default is at a certain quality, right? So in AWS's case, when you're dealing with when you're dealing with symmetric encryption, it automatically gives you AES 256 GCM, which is the strongest possible mode of encryption in AES and the highest key size for AES, right? So it's AES 256, which is 256 bit, and GCM, which is the Galois counter mode, which is authenticated encryption and not just encryption, right? So it's authenticated. So there's also an additional element of integrity verification to each encrypted round that you have. And of course, they also give you access to RSA-based keys, ECDSA keys for signatures, and so on. So you have all of those possibilities. Azure is a little bit more asymmetric centric. The master keys in Azure are typically asymmetric. And of course, you can wrap them in symmetric keys, but they start off as an asymmetric key. And with Vault, of course, you have a variety of choices. Vault, again, defaults to these secure defaults by, when it starts off itself. So it also gives you an AES 128 GCM, SALSA 20, which is considered a very fast and safe cipher to use. RSA's more secure modes and secure padding algorithms and channels, and of course, padding algorithms, and of course, ECDSA for signatures and so on. And of course, they give you a lot of logging options as well, right? So they give you a lot of options to be able to log your data and manage your, do your audit trails for your encryption and so on, right? So that's something you can do. Now, one of the key things that a lot of these cloud providers give you, and of course, any good cryptographic solution should give you, and probably does, is something called envelope encryption. Right now, envelope encryption is essentially for multiple reasons, and I'll talk about what that means. So I'll just go through the flow, and then I'll also do a demo with envelope encryption against on AWS. Right. So you typically start off with a customer master key. So think of this as the master key for. So let's say you have an application. So let's say I'm launching an application called Acme Web Service, right? So it's an Acme Web Service. It's a new application that I'm launching, and I want to encrypt, let us say, credit card numbers in this application. And when I want to store in my database, I want to encrypt the credit card number. Now, as part of this, let's imagine that I have a requirement that says that each user should have their own encryption key. So let's say we have identified that, for better security, better safety, better, privacy, we want each user to have their own encryption key, which is used for that user's data, which is encrypted, right? So let's say I'm Abhay, and my data on the system on Acme Web Service is encrypted with a key that is specially for me, right? So let's say that's the use case. Let's take that as an example and say that's the use case. So I want to be able to achieve this. Now, how do I achieve this? First of all, there is a slight challenge. I want a key for myself. So each user has their own key. And aside from that, obviously, I want to be able to protect that key. Remember, I need to be able to protect that key, right? It's not just about storing into the key and storing that key plain text in the database. Pointless. Now let's look at how we can do that. So typically, when you're wanting to do something like this, you want to generate something called a customer master key. So that's the service level master key, right? So that's the encryption key that is used by your service at a master level. Right. Once this is done, what you want to do is you want to generate data keys. Right. So whenever I access the system, I should be able to generate a data key for myself that essentially encrypts the data. So let's say I have stored my credit card number in the database. The key that actually encrypts that data is the data key, which is generated from this CMK, right, or the customer master key, right? So the customer master key decrypts the data key that encrypts the data, right? So it's like a two-step process. The reason for this, like I said, is multifold. One, you can store the encrypted version of the plain text of the data key in your database. You can store the encrypted version of the data key in your database. Whenever you want to decrypt stuff, use the CMK, decrypt the data key, use that to decrypt your data or encrypt your data, as the case may be. So it becomes a much more secure process. The second thing is that the cloud providers have designed the CMK in such a way, because when I say CMK, I mean customer master key, in such a way that the CMK can only encrypt a certain size of data. It can't encrypt a huge file. So let's say I'm uploading an image file that's, let's say, 4 meg, and I want to encrypt it. That's not allowed. So typically it's about, I think Azure gives you 4 KB of encryption, and I think AWS gives you about 40 KB or something. I don't have the exact limits, but that's typically how the size of the data that you can encrypt with the CMK. So when you're encrypting large data sets, you want something that's more optimized for that, stored in a source that is closer to the data so that you can access it faster. It's much more performant. At the same time, it's secure because that key is encrypted with another key, right? So you have both these benefits, right? So let's look at a demo
Just before we pray to the demo gods, I'm going to pose a couple of questions that are in the chat.
Yeah.
So the first one I see here is, how do the more traditional PAM vendor options compare? We'll have to sort of go through our metrics when this came up.
Yeah, I'm actually seeing those. How do PAM vendor options compare? Again, in terms of the encryption, they would probably be using these services under the hood, is what I would assume. I am not checked out any of these per se from an audit or assessment perspective, but I'm assuming that most of them have a similar set of encryption capabilities under the hood, or at least should have designed it for that. Most of the OAuth folks typically do it. They typically implement a very similar key management system, but I'm not sure about the other PAM vendors, to be honest.
So the next one from Vincenzo should be, and maybe this is more sort of like a heading kind of thing. Shouldn't keys in quotes? Oh, there it is. Shouldn't keys?
Yeah, unlike secrets, they probably shouldn't be accessible to any application. Yes, that's right. One of the things I forgot to mention: keys don't leave the key management system. You actually never have access to the CMK. You can never see the CMK, or you can never store the CMK, right? The CMK can only be accessed through an identifier. So it's kind of like a secret. So you just say, hey, give me key ID or encrypt. So I want to encrypt this credit card number with key ID 1234, and it'll just give you back the ciphertext. So you're absolutely right. Yes, the key never leaves the HSM. The key never leaves the key management system as well.
Okay. Quickly, I'm going to invoke MC privilege here and ask my own question, particularly around AWS KMS. I wanted to get your impression in terms of, it seems like, in the space of me asking this question, AWS will have created a new service. And so between KMS and parameter store and their management services that had some original key management mechanisms, what has been your experience in terms of the difference? Do you have any sort of insight for us between those seemingly similar services?
So you're talking about the differences between parameter store and secrets manager, correct? Yeah, so that's a good question, and a lot of people have this question. So parameter store is the first thing with parameter store is that it's free, right? So you don't pay. I think up to 10,000 key value pairs, you don't pay or something like that, some crazy number like that. You don't have to pay for it. So it's usually the cheapest option that you have to store the secret in your parameter store. But with secrets manager, you have to pay. I think you need to pay 40 cents per secret or something like that. Again, I'm not sure about the pricing, but you definitely have to pay per secret. The thing with secrets manager that is slightly beyond the parameter store is that secret manager gives you the ability to rotate the underlying key that is storing the secret. Parameter store does not.
That's very important.
That's number. Yes, that's important, especially if you're dealing with a very critical type of thing. It's in parameter store, it's still encrypted. Not saying it's not, but with Secrets Manager, if you want to be able to rotate, then you need to use Secrets Manager. That's point number one. Point number two, Secrets Manager also gives you the ability to generate random, cryptographically random tokens as well. So let's say you have a service that requires you to generate these cryptographically random tokens for your user. So let's say you want to use that in, let's say, generating some auto-gen password or using that as a some kind of a nonce or whatever, right? You can use Secrets Manager. It gives you a cryptographically secure token every single time, which parameter store does not. So these two, yeah. I'm not sure. Did that answer your question?
Yes, it did, actually. Thank you.
So shall I go ahead with the demo? If we are
let's tempt fate.
Yes, no, I think the demo should go fine. It's deployed serverlessly, so I don't think I should have a problem. So I am just going to bring my Visual Studio Code, and we'll try and get done in 5 minutes. All right, so I'm just going to quickly run through the code here. So here is a classic case of, I'm using all three things. So I'm using secrets, which is the key value pair that I'm talking about. I'm also using envelope encryption. So envelope encryption is where you use the the CMK to generate the data key and use that data key to actually encrypt and decrypt data, right? That's the envelope encryption aspect. Now here I have a serverless function, and I'm using DynamoDB for that serverless function. So like I said, the use case here is I'm a user, and every single user gets their own encryption key, right? That's the example here. Okay, so every single user gets their own encryption key. So let's talk about what happens here. So when the user signs up, so I use a CMK and generate a new encryption key, new data key for that user. So let's look at this line of code here. So I use the KMS API of AWS, and I generate a new data key. Now this gives me two things. It gives me a plain text blob and a ciphertext blob. Okay, plain text blob, ciphertext blob. The plain text blob, obviously, I shouldn't be storing. That's, I think, goes without saying. But what I can do with the plain text blob is encrypt or decrypt whatever actual data that I want to encrypt or decrypt. So in this case, if you see what I'm doing, as soon as I create the user, I'm using the plain text blob and encrypting my password. Okay, but I'm actually storing the ciphertext blob in my database. Okay, so let's be clear. Plain text blob is used to encrypt the password, but the ciphertext blob is actually stored in the database. Okay, so this is the one, and I create the user. Now the password is encrypted, and I have an encrypted data key. Now when now every time I want to do something, when I want to log in, I decrypt my password. Remember, I first decrypt my data key, and then I decrypt my password, and then I check my password, and then issue a token. Now the token comes from your parameter store. So this comes from the parameter store, which is invoked on top right here. Right? So parameter store invoked on top right here. All right, so that's what's happening. And then what I'm going to do is I'm going to store a credit card number here, and that credit card number is also going to go through the same thing. So the credit card number comes in. I'm going to decrypt my data key, use the data key, encrypt the credit card number, and then that's it. Right? It stores the encrypted credit card number. So and when I decrypt it, the same thing happens. So it's all envelope encrypted. So let me just run the example, and I am going to have to, yeah, just 1 second, please. All right. So I want to sign up as the user here. Email. I think I have some canned data, so I'm just going to use this. I'm going to use an extremely complicated password called hello. Oh. Sorry about that. I thought I had installed this. My bad. I'm going to create my user. Remember the password. Yeah, so the user is created. The password is encrypted and the data key is associated with that user. So I'll try and show that as well towards the end. Now, when I log in to this account, what it's going to do is it's going to decrypt my password from DynamoDB, and it's going to generate a token. Now, this token is generated from a password that is stored in my parameter store, right? It's stored as a encrypted secret, right? So that's what's happening here. Now I'm going to create a card. So I'm going to create a card number here with the token. So I'm just going to actually copy this token. Oops, sorry about that. Butterfingers. CDP post. I'm going to actually go to my card, post request, and the authorization. I've JQ'd this and made things a little easy for myself, but hey, I'm going to store this as the card number. Now this generates the card number. It's going to create a new card. When I actually have to get the card, I can get the card. Now, in the meantime, let me also try and log into my AWS account and actually see if I can pull up the data from that data set. Just give me a minute. Looks like I have officially run out of time, but just give me a minute. Let me try and finish it up. Sorry about that, folks. I'm just trying to pull up the password for this account. Just give me a minute. And I have a multi-factor authentication code that I need to apply. Sorry about that. Just finish that up.
Never apologize for multi-factor authentication.
Yeah. Unfortunately, when you are in a bit of a rush, that's exactly when that slows you down. Oh man, looks like I got the wrong password.
That never happens.
Yeah, so I think I have a bunch of the Amazon. I have so many Amazon accounts. It's just embarrassing. Yeah, you should do it. Yeah. Here you go. Hopefully it's on. I'm not sure which region it is on. I think it's on US East 1. I think that's where it's deployed. Let's go to DynamoDB and let's have a look at. Hopefully it's on US East 1. No. US East 2, West 2. Yeah, here we go. Sorry about that. Again, it's, yeah. So you see that, let me just show what's happening here. So the user has a password, and remember, so the key here is the actual data key. Now this is the encrypted data key that we stored. right? And this is encrypted and decrypted by our master key. So the master key is managed by AWS itself. It's essentially something that we just generate. So we don't have access to the master key. We only refer to the master key by the key ID. So if you even look at my code, you will see that that's exactly what's happening. The master key is only referenced by the environment variable, which is the key ID. It's not the actual master key. So I never actually have the master key, right? So in here, the data key is the one that is encrypted and decrypted by the master key. But all of the data from this, the credit card number and the password, all of this is encrypted and decrypted with this key, right? So it's like a two-step process. Every single time I want to encrypt, I have to first decrypt this and then encrypt something. Every time I want to decrypt, I first decrypt this and then decrypt the actual data, right? So this one, it helps in 2-3 ways. One, of course, you can't encrypt large data sets directly with the master key. And two, it also helps because it kind of keeps it close to the same data source. So you don't spend too many API calls going back and forth, especially at scale. So it really helps keeping things performant and also keeping things segregated, right? So what it really helps with the fact that as a user, you can have, especially when you delete this user, you're deleting all of the user's data sets along with it, rather than having a possibility of have some kind of access even after this user leaves your system, so on and so forth. So you might have some regulatory requirement, a contractual requirement to have this kind of a system in place. So I'm just going to quickly wind up. So like I said, with the cloud, one of the cool things is that we are reasonably in good hands because the APIs, the tools are already there. We just have to architect and design for it. Again, it's easier said than done in many cases, but it's possible. Today, it's much more possible than ever before. So that's one of the benefits of this. And of course, access control is very, very important. Even with my stack here, access control has been implemented, I think, to a reasonably not so horrible extent. So you can see that the access control has been implemented specifically. Only this particular key can be used. Only this particular password can be retrieved. So there is a clear access control restriction for this particular stack that we have. So that's something that you have to do even on the cloud. So access control is something you can't avoid just because you're on the cloud. All right, with that, I come to the end of my presentation. Thanks so much. I know I'm kind of running a little bit over, but I hope all of you enjoyed it. I hope it was useful. Thank you very much.
Awesome. Thank you very much. I particularly was interested in this because back many moons ago, I was involved in key management, but in the world of server monoliths. So it's really nice to see that a lot of the things that a lot of organizations had to bespoke to create some sort of key management mechanism, you get a lot of that, well, depending on what service you're using, mostly for free. But there's really, in a lot of ways, no excuse that secrets management can't be implemented because you're given all these tools and infrastructure in a cloud infrastructure. So it's definitely a watch this space, provided that you've deployed the appropriate infrastructure as code that's giving you the right access to the right things. So this is really an exciting area. So I'd really like to thank you for being able to share this with us. I'm sure there's going to be a lot of people will be going to be looking up references based on this. And we will of course, this is recorded. This will be on the YouTube channel, and we can share any links through our traditional sources. The only thing I'll add is that if anybody listening wishes to share with us, we have a sessionized link, and check our Twitter handle for details on how you can submit presentations for any future talks at OWASP Ottawa. So again, thank you, Abhay, and stay safe, and we'll be talking to you in the future.
Thanks so much. Thanks for having me.
All right. Thank you.